Today's webinar, as you already know, is Lab Skills for Network Engineers. And our speaker today will be laying some foundations and then specifying some criteria and prerequisites that could turn around your labbing experience, right? And he's also going to highlight some labbing skills, make some analogies and comparisons. And this is very important, especially if you're a beginner. This is very important because this one webinar can save you months or even years of unnecessary frustration, right? And even if you're an intermediate engineer, this webinar would give you that, aha, I knew I was doing something wrong moment, and it could totally clear away the bottlenecks you've been having in your career growth that feels like you're dragging a truck up the hill. And so please, if you have your pen and your paper, and I'm very serious about your pen and your paper, like I said, this webinar is value packed. So if you've got your pen and your paper and you've got your 6 senses a lot, then please join me and welcome our speaker, Mr. Mubarak. So Mr. Mubarak Abiola, thank you very much for accepting our invitation. We are glad to have you here, and the stage is yours.
Thank you, guys. Thank you, Fanaya. And I'm also glad to be here. Hello, everyone. My name is Mubarak. I was introduced by the and I won't waste most of the time. We dive directly into why we're here. So, why most people quit labbing? And we need to understand that. I think that's the first thing we need to understand, and how not to be one of them. That is the reason why we're actually here to do it. And there are many ways at which you can lab. There are many environments at which you can use to lab. However, most of us, when you're trying to lab, we face a lot of challenges, and I will try as much as possible to highlight and explain most of them. SAT will, if you're preparing for your SAT, let's say CCNA, CCNP, you would want to pass your exam. And aside from passing your exam, you want to be able to demonstrate those skills directly in production. I won't lie to you, the skill that you're getting in lab environments is quite not exactly what is on site. Why? The difference is because the pressure that you feel while trying to configure something in production is not the same way you would tackle any kind of, let's say, troubleshooting in labs. For instance, I can decide if the device is giving me any injury in the lab, I can decide to just wipe that device. I can decide to just wipe that image. You can't try that in production. You understand? Now, the first thing we're talking about is what SAT will test is just recognize you should be able to pass an exam. Anybody can pass an exam. If I teach someone subnetting today and they're able to understand it, they might be able to say, okay, I know how to subnet. They can use that, those skills in the exam. They might be exam smart. However, when it comes to configuration, you need mastery, you need confidence, and that is why you need to learn. You understand? So when you get to your job, the demand is you're troubleshooting live failures, live, and you need to be doing things from your memory. How? Because you've been doing it in seclusion for a very long time. So lab environments gives you that mastery, gives you that vibe of, yes, I can do this thing. Someone was telling me earlier today that in an interview, he was asked, can you configure VLAN? And I was like, what kind of question is that? Because I know this guy is a very smart guy when it comes to labs and all things. Okay, can you configure VLAN? It means the interviewer might not be able to configure VLAN. That's what's suggested. So you want to separate yourself from everybody that is in network engineering or that is in cybersecurity. Labbing is not only for network engineers. I believe some people might just want to do CCNA, and from CCNA, they go into maybe hacking and all those things. Your lab environment, the same lab environment that I, as a network and security engineer, will use is almost the same lab environment that anybody in engineering, software engineering, might want to use, depending on the environment. Now, let's talk about the environment. So, your lab environment could be a physical machine. What do I mean by physical machine? I mean, your laptop, I mean, it is local. You have access to your device. You can see your device. You have a laptop or you have a server. You understand? Now, it could be a physical machine, your laptop that has compute power. You don't usually need internet. Depends on your topology, on what you want to achieve in that lab. You understand? You don't really always need internet, but there's a way you can use internet in your labs. You can ping the internet, you can relate with the internet while you're labbing. So the advantage is that you have access to your compute power physically, locally, and you have faster access to your disk, to your drive, and you don't incur any monthly cost. As opposed to the cloud environment, let's say Azure VMs, AWS, and other cloud environments. You can also have CML cloud like that. You need to pay money. But the advantage is that you can lab from anywhere. You can lab from anywhere. You can scale your lab. You can work with other people while you're labbing. You don't have that kind of advantage when it comes to your physical lab. You understand? So your physical lab could be a server that is a desktop machine that is dedicated for your lab, or a laptop that is doing both your day-to-day activities and your lab environment, depending on the capacity of those devices. Now, when you hear lab environment, lab skills for network engineers, the first thing that comes to your mind that I will be able to lab all this that we're talking about is the foundation, is the nitty-gritty for you to be able to lab effectively and efficiently. Because at the end of the day, a lot of people stop labbing because they don't really understand some important aspects like your machine, the environment that you're labbing, the capacity. And that is why most of us are not. It's not because you don't want to. No. So the things you need, the cons for physical environment is that, you need to secure a good machine, a machine that can serve you. What do I mean by that? A server that can serve you. And if it's a server, you can't be carrying a server everywhere you want to go. But if it's a laptop, you can carry it. However, the wear and tear that comes with you using the laptop for labs and all this is also, but there is a lot of cost that you want to incur depending on what you want to use that environment to. So it could be local environment and it can also be a cloud environment. So you can deploy your lab in an AWS VM, you can deploy your lab in an Azure VM, you can have an EVNG cloud and a lot of cloud environment. I think every one of us understand what it means for you to deploy a server in the cloud. So because your lab is also a server. Now, so but you incur cost, monthly cost, GUI latency, and bandwidth dependent. If your internet is bad, you don't have access to your lab. And let's say you need to do a proof of concept in, let's say in 30 minutes, and your lab is in AWS, and AWS is down. What would you do? And those are the cons when it comes to the kind of environment that you want to use. Now, the capacity of those compute. Now, the capacity of your laptop, of your server, will determine what you can do. Now, that's what I think a lot of people ignore. So people just say, Dad, you can just call your dad, I need a laptop, I want to be labbing, I want to do network engineering. And they'll just bring you any kind. One thing you need to watch out is that what is the capacity, the compute power of your laptop? Now, the first thing, let's look at the RAM. If you're doing anything that is, if you're doing anything around, let's say, packet tracer, IOL labs, and you don't do too much, you just want to spin out some CCNA labs, you might be able to use anything around this. Why? Because 8 gig RAM, your host machine would take some of these capacities. Your host machine might take like, let's say 2 gig RAM. Most times it takes half of your, depending on the OS that you're using. If it's Windows, it is very aggressive with your capacity. It might take like 4 gig out of your 8 gig. It might take like 8 gig out of your 16 gig. And you notice that your lab is lagging, you're dragging with a lot of things. It is because you are not noticing that, one, your RAM is very low. If you, whatever RAM that you have is what you will share with your devices in your lab. You understand? And whatever CPU cores that you have, this, and a lot of people might not know that you need to understand the architecture of your CPU. So Some CPU are 4 cores, some are 6. So if you want to do something minimum, you want to be on this spot of 4 to 6 CPU cores. Those are physical cores, and they are multiplied by 2, usually depending on the brand. So multiplied by 2, if it's 4 CPU cores, I have 8 logical cores. If it's 6, I have 12, depending on the kind of brand I'm using. If it's Intel, AMD, or ARM. You understand? I'll show you this I'll show you how it actually works from my own host machine. So you can be comfortable using 16 gig RAM to 32 gig RAM with 8 physical cores to 12 CPU cores. Now, if you multiply this by 2, it gives you an opportunity to have labs that can eat out of, let's say, 8 times 2 is 16. That means you have 16 logical cores. Then you can do something from solid CCNA labs, solid CCNP labs with 32 gig RAM. You understand? And up to 12 cores. These 12 cores will be 24 gig RAM. Now, you're better off using this, depending on, but you can use, now, I don't want to push anybody to be like, maybe I don't have something enough. I'm just letting you know the limitation of whatever you're using, whatever your machine is, whatever your server is. And that would let you understand what happened for enterprises that they deploy their infrastructure in the cloud. Now, a cloud is not in the cloud. It is an environment, it's a data center of another person. If I put my lab in cloud, it's that particular lab that I'm using, either CML, EVNG, or PNet lab, is being deployed on a particular server in AWS or in Oracle, whichever cloud I'm using. I want us to note that. So the more capacity that you demand from your provider, from your cloud service provider, the more it costs you. And it happens also physically. Your local devices, the more you want to upgrade your RAM, upgrade your CPU, you want a better laptop, the more it costs you. Today, if you want to buy a DDR5 32 gig RAM, it's around 350 to 450,000 naira, just a RAM in Nigeria. And depending on the product, the quality that you need, you understand? So we need to be, you don't just buy laptops as a networking, especially if you're a network engineer. You don't just buy laptops, you don't buy servers. They must be able to do what you want them to do. You understand? So when you have something that has the capacity of 32 gig RAM to 32 gig RAM upward, you can have up to 1 terabyte of RAM, depending on how you can. And you know that if you're having, just imagine you want to have 1 terabyte of RAM, and 32 gig RAM is from like 350 to 650. Kingston 32 gig RAM is around 650,000 naira. If you convert that to dollars, around maybe $400, around $500. Why? Because the AI era that we are is letting all these things hike in price. So before we actually jump into labbing or no labbing, we need to understand the architecture that you're using, or you have a headache from it, or you just stop using. So what is the effect of the brand that you're buying? If you're buying an Intel, most of the CPU that Intel CPU that you have from let's say 7 to, from the 10th gen, 7th gen to like around 14th gen, the cores are divided into 2. Sometimes if you have like, let's say you have like, if I have like 8 cores, if I have 8 cores, the hybrid core, the P cores, they call it performance cores, can be, let's say 6, and the efficiency score might be 2, making that 6, making that 8. That means it is only these guys that I can use in my lab efficiently. These guys will be doing other things. And that's the effect of you using an Intel. You understand? E-cores never have hyperthreading. That means they can't do nested virtualization. So nested virtualization means that, it means that I have my host machine, then I now put EVNG inside my hosts using whatever type of hypervisor that I'm using. Do you understand? Hypervisor. Then my host machine, maybe PNet or EVNG. Then inside EVNG, and I have iOS images. That is nested virtualization. We've nested this virtualization. Now, E-cores are not doing that. They are not doing that virtualization on all those things. But when it comes to AMD, you understand? AMD, they're Ryzen or whichever AMD CPU that you're getting, it gives you an opportunity to use up almost everything. If it's 8, it's times 2. So you get 16 logical cores. And we need to understand the difference between physical cores and logical core. The physical core is the cores that your CPU comes with, CPU pin cores now. It comes with just 8 cores. But logically, it can give you twice that your physical core, depending on if it is Intel, AMD, or AMD. Now, when we go to ARM, ARM is Apple Silicon or Snapdragon. Apple from M series, the Apple M series, they use ARM. So if you want to buy Apple now, and you say you want to use Apple laptop to do network engineering labs, you struggle. I bought an M series, I got an M1 in 2021. I was frustrated, I had to let go. It's a very solid laptop, I love it. I just had to let go to go back to an AMD. You know why? ARM doesn't support nested virtualization. I don't know if they will support it tomorrow, but till now, I'm not sure I've seen anybody that will say, I'm able to use ARM architecture, Apple Silicon. So if you're buying M series lab, I wanted to inform, I just want to inform you now that you struggle with some things to have your lab. However, you can use some things like container labs that are deployed. So if you're using an ARM, that means you want to deploy your lab on someone's server. A friend might have a server. You can say, okay, deploy this Pnet lab, deploy EVNG for me, give me a VPN tunnel to my laptop, and I'll DP to that server. I'll just be using my ARM. You understand? Those are the difficulties that you might encounter depending on the RAM, on the CPU architecture, or the brand that you're using. And a lot of people don't know this. They just want to get laptops. So that's one of the reasons why we need to explain all this before we get into labs. So remember, I was saying type of hypervisor earlier. So what type of hypervisor are you using? So if you're using bare metal, ARMs are logically bare metal. Apple owns the CPU. That means Apple will let your VM interfere immediately with your CPU without needing to talk to the OS. Do you understand what I just said now? Now, what's the structure of virtualization? The first thing you have is your CPU. Let's say you have Arduino. I think kernel. Then, can you even see my writing? Then we have OS. Then we have our VM. What type of virtual machines? No, we have our hypervisors. So it depends if it's type 1 or 2. You understand? But when it comes to ARM architecture, the Apple Silicon, it lets you directly, it lets your hypervisor talk to this guy, to the kernel directly, without giving you all the overhead that the OS will give you. So that's the disadvantage of you using a Windows or an Intel. So the type 1 hypervisor and the type 2 hypervisor, it means bare metal, you run it directly. Thank you so much. You run it directly on your device. Bare metal. That was why I was saying, if you use an ARM, it will let you feel as if all these Apple Silicon, they are very powerful. It lets you feel the energy, the full power of that CPU and your RAM, as if it is bare metal. Whereas it's not. You're even launching like something like a VMware Fusion, or I think VirtualBox was an ARM. You understand? So, but remember, nested virtualization doesn't work. You can use some things like container lab because you use Docker. Docker works. I think Docker desktop works on ARM. If all these things that I'm mentioning, if it's something that you can't relate to, I understand. But a lot of people should be able to relate to. You understand? They are the reason why you think I can just spin up my lab in Pnet. All the struggle you are facing is because of all these things that you don't really take cognizance of. Now, it's bare metal is type 1 hypervisors. So they run directly on the hardware. The whole machine becomes your lab. That means if I have a server now, I put something like this will be my virtual machine, my virtual machine emulator, and Proxmox VE. So you can, that means if I put my Pnet lab or EVNG on it, or CML on them, the ISO file, it will feel as if the only thing that's running on that device, it will feel as if the device is my lab. Do you understand? Bare metal, that means I put everything. There is no OS level at all. You understand? That's for bare metal. But when it comes to type 2 hypervisor, it is hosted by a virtual machine, like the VMware workstation, the VirtualBox, and Fusion for Macs. You understand? However, Mac M series lets you feel like you are using DNA type because Apple Silicon is also Apple's CPU and the OS is also Apple. You understand the logic. So when you're choosing your lab environment, please take cognizance of that. So I want to open my VMware now. I don't want to talk so much because of our time. I want to show you guys what it is. So remember, we're talking about type 2 hypervisors. So this is a type 2 hypervisor. This is VMware workstation. And if you are a network engineer and you're using a type 2 hypervisor, I would advise you to use this. VirtualBox is not bad. It's not, the only thing is that VirtualBox is not that complicated. You understand? This gives you control over whatever you want to do. Now look at this lab. Look at this. I call it my lab. That is my lab environment. It creates virtual machines for you. It hosts your virtual machines. You understand? Now, I have Linux Mint. This is a virtual machine on its own. I have Pinet Lab. It's a virtual machine. I have an Ubuntu server that is doing, maybe I want to host a web server that wants devices in my Pinet. So it gives you an opportunity to do a lot of things. Your networking will be clean. It's also clean in other one, but this is the one that after trying a lot of them, I think this, and you will see a lot of engineers use that because it gives you control on your networking. It gives you control on almost every aspect of what you are creating. Now, I'm hosting Pinet Lab. I'm hosting Ubuntu server. I'm hosting OpenSense firewall. This is a firewall. It's an open standard firewall. You understand? So this Kali Windows. This is a Windows server. Now, I have all this because I don't want to have my Windows server inside my Pinet Lab, and I have to create spin-up for every instance of a lab that I want to do. Let's say today I want to do 2 sites. I want to have 2 sites that has an LDAP server on my Windows server. So if I create that inside my Pinet, that means I'm restricting myself to say whenever I want to do another lab that needs a Windows server, or I need an LDAP radios, or whatever server, I need a DHCP server, I would need to now recreate that instance again. If I have this, I can connect this. I can put this guy in the same subnet that I have my Pinet Lab. Look at this. I have a NAT adapter here. And this NAT adapter, if I look at my Pinet Lab, I also have a NAT adapter. What did I tell you? Pinet Lab has a subnet, has an adapter that can talk to Windows Server. Do you understand that? If I open this to this OpenSense, I have a NAT adapter soon. So that means I can attach this guy inside my lab to this guy and to this guy, and they'll be able to talk. So if you have your virtual machine, you want to, this is where you do most of your setting. Let's look at memory. I talk about memory. Before I come here, let me show you. So let me show you what my host machine is all about. It's like the composition of my host machine. So if you right click, if you're using Windows, if you right click on your taskbar, you can see Task Manager. Any laptop that you want to buy, you need to do this. Then here you have the processes, and here you click this one. It shows you the performance. This will tell you almost everything about that machine. Nothing they can add. They can add nothing from you. You understand? When you come here, there are also other ways that you can try to check. Look at my CPU. The name of my CPU is AMD Ryzen 9 7845HX with Radeon graphics. Immediately, just search Google. Check what people are saying about that CPU. You understand? You need to be very, you need to do your due diligence, or else you buy a problem. Now, there's something about AMD CPUs, AMD architecture that you need to know. I must tell you, it overheats a lot, depending on the model you're buying. You understand? It overheats a lot. If you can be like me and you can endure the overheating, but you love the raw power that it gives you, you can go with AMD. This particular CPU, these are the features of it. I click this, I have access to this. The socket is just one socket of CPU. And how many cores do I have? I have 12 cores. And it gives me logical cores of 24 processors. I'll show you what that means when we get into our VMware. So virtualization is enabled. How? There's a way you enable virtualization in your, there's a lot of processes to that, especially when you're using AMD. It might not work the way it was on Intel. These are one of the things that you need to do your own research on. So virtualization is enabled. This will tell you the capacity. The best speed of this particular CPU is 3 gigahertz. That means it's telling you that it's fast. And let's move to the memory. It's a 32 gig DDR5. This guy is very expensive. The least you see in the market, depending on the product, is around 250, 300, 450, 650. This just only one stick. And how many slots do you have? You have 2 slots. It's saying slots used, 1 out of 2. And the speed is 5,200. Why am I telling you this? The higher the capacity, the higher the stuff that you can do. Your lab will not lag, you have speed. This is still like a baby from the things that we are supposed to be using. But this will do enough. It can even lab CCIE lab, depending on how you are labbing. You understand? So we have, this gives you an opportunity to see almost everything that is running, the architecture of your laptop, of your device, depending on the OS that you're using. This is a Windows OS, Windows 10, Windows 11. I think they are similar. So these are the adapters that I have. These are created in VMware. I'll show you guys. Now, don't forget all these things that I just showed you. I'm showing you not to show you my laptop. I'm showing you to show you why they are very important. Now, let's go back here. When I'm creating a virtual machine in a type 2 hypervisor, the memory is the first thing, which, okay, let me go back. Let's use PNetLab. So let's edit. You edit the virtual machine after you've installed it. I would have loved to go through the process of installing PNetLab, not in this class, because if you start, I don't know when we finish, but these are the most important things that you need to know. Now, the memory, I'm using 16 gig for my lab out of 32 gig. That means I'm dedicating 16 gig for my what? For my PNetLab. My processor is, you remember that I have 24 cores from my 12 times 2, 24. So I can buoyantly say, okay, give me 10 out of 24. I want to use 10 inside my PNetLab. So devices will share those 10 cores between themselves. If I'm using an heavy device, I can give it 4. You understand? So the more powerful your device, the more you can allocate CPU cores, RAM to your device, to your lab. My hard disk is 100 because I have 1 terabyte. So I added 50. I also added 50. The way my lab is growing, I kept adding. I kept adding more labs, more disk capacity. So I have a bridge adapter. What is a bridge adapter? So let me show you. So what is a bridge adapter? Let me close this first. VMnet O, when it comes to VMware, VMnet O is your bridge. What is bridge doing? It gets its own LAN IP, behaves like a physical machine on your network. Now, why? Your router will give you an IP. Your router is giving this guy a bridge. It's like a bridge to your network, to your router network, to your home network. Do you understand? So you are bridging into your home network. This adapter will give you access. If your router has access to internet, this adapter will give you access to the internet. You can run, someone asked that, can you run PNetLab on Proxmox ESXi? Yes. I've mentioned that earlier. Remember, I said you can run all these instances. Now, note something. PNetLab, even the CML, they are like a server. They are like a server image, ISO image that you can launch or that you can launch on any environment that you want to launch it. VM, it doesn't matter if it's a bare metal. You can launch them, but I've mentioned a lot of roadblocks that you can make depending on your choice. But if you have a server, let's say I buy a desktop server or any desktop, I have, let's say, I have a DDR3 RAM. Those DDR3 RAM are very cheap now. If you want something that you can use, I use Ubuntu bare metal and make use of VirtualBox. Can I run PNetLab? Yes, of course. Of course. That was why I was explaining to you. There's a difference. Now, the bare metal or hosted, we have 2 types of hypervisor. Is it type 1, which is bare metal? Is it type 2, which is hosted? You understand? Your type 1 gives you an opportunity to run your servers, your PNetLab, your labs directly on those kernel or on the hardware. So you take advantage. You don't have any overhead. What do I mean by overhead? Overhead is the kind of load that hosts. Okay, let me give you an instance. Look at what Windows is doing. Let's say, so Windows is taking, look at all these processes. They are taking memory. They're taking almost all this 46% of my memory. But when you use bare metal, you don't face all this. Most of your memory is allocated to that server. Do you understand? Because you are interfacing your PNetLab, your CML, your EVE-NG are interfacing directly with your hardware. Do you get the differences? But when it comes to type 2 hypervisor, your type 2 hypervisor like VMware, like VirtualBox, we need to talk directly to your, what's it called, to your OS, which is Windows. Now, all these processes that are going on, they'll be taking memories now. So that means they are eating out of, okay, let's look at my memory now. So my memory is using 14 gig out of 32. That means I allocated 16 for PNet Lab. That means this 14 gig, if I'm not careful, this background work that is going on in my OS will affect what's going on in my PNet Lab. Do you understand? That is the advantage and disadvantage of using any kind of environment. So you need to clear most of the things that you are doing. If you want to go heavy with your RAM in your lab, depending on how big the lab is, you need to clear some kind of background work, remove them, so that you have now I don't have efficient 16 gig is available. The moment I start using 16 gig, I won't have issue. 16.8 is available. This 14, my host is using it. Do you understand? So that's the difference. Bare metal give you access. Your bare metal means that you put EXI or Proxmox. They will now be, Proxmox is the one that will now be hosting your Ubuntu. It will be hosting your PNet Lab, hosting any server. Your Ubuntu is like a server. The same way my Ubuntu is a server here. My Ubuntu server is a server here. It's a VM here. I have an Ubuntu here inside VMware, type 2 hypervisor. So the difference is that my bare metal give me access to the hardware directly using Proxmox. Do you get the difference? I was talking about bridge network, and VMware networking is where a lot of us we get it twisted. VMware networking will mess your lab up because you just notice that one thing cannot ping one thing. You cannot talk to which other server that you want to talk to. You cannot ping. So, from my explanation earlier, from this PNet Lab, I can ping devices here. This guy can ping this guy if they are in the same subnet. Having this adapter is putting this guy in the same subnet with this guy. If I enter my PNet Lab and I connect them together. So the same thing that your Proxmox will do is you launch your VMs, your Ubuntu will now be a VM, your OS will now be, I can even have, this is a Windows OS, Windows server, is a Windows OS. So I'm having a Windows OS inside a type 2 hypervisor on a Windows host machine. And you guys will make. So my PNet Lab has bridge, it has NAT, it has custom, which is host only. So let me show you before. So we can have NAT, the bridge puts you in a subnet, in a network where your host machine is. That means my host machine can ping, I can access, that will give me access to I can use it as an access to the internet. That means devices in my PNet Lab can ping the internet inside the PNet because it is in the same subnet as my host machine, as my router. Do you understand? Now, if I use NAT is what I use as a management VLAN for myself. So this is my NAT. You'll notice that most of my my servers, or let's say most of my VMs, they have the same NAT. So a management VLAN whereby if let's say a 40 gig device now, you need to configure it. Some of it, most of it aspect, you need to see the observability, have access to the GUI. This NAT is the IP that I want to use. I can also put it in bridge and also have access to it in my web browser. Do you understand? So NAT is another subnet where you can put your devices, like just put them in a managerial subnet. So you can create a network adapter. This is a custom. I can also use host only depending on what I want to use. You understand? All this will reflect inside your PNet Lab. This is the advantage of using a virtual machine. If I turn on this device now, this PNet Lab, what I would notice is for my own machine, what I will notice, if you can see this, I'm monitoring my CPU heat. It's going to 80. I'm monitoring my CPU, I'm monitoring my GPU. I didn't talk about GPU since because it's not that important when it comes to network engineering or whatever we are trying to do. Your GPU is very, very important if you are hosting your lab in a cloud and your web access need is not something so you can use lesser. So the IP address of my PNet Lab is the IP address of my router or whichever network that I'm connected to. Now, notice something. I'll show you this. It's very important that I show you. So this IP address here is 172.20.10.3. I can use this IP address to go into my web browser. and I'll be inside my, you can all see my screen, I believe. So 172.16.0. What? No, .20.10.3. So now I'm inside my pnet. So I'm inside my pnet. Admin. So I have this topology. Now, where is my, so one of the most important things that you need to keep checking is the system status. You need to start checking your CPU. I have 10 cores, but I've only used 10% of them. I have 16 gigs, I only use 7%. I have, so there's a 4 gig swap. That means if you use up all this, you can start swapping from your host machine. Because the bridge adapter connects you to the hosts. The host is in the same subnet as the bridge. The bridge connects you to the host. Are you listening? The host is my laptop. The IP address is coming from my router, whichever internet I'm using, whichever access I'm having. It's like you being in the same subnet. Network engineers are here. It's like you being in the same subnet as any other device. You understand? The gateway that I'm using is .1, which .1 is my laptop is, my host machine is in that .1, that bridge. My pnet lab server is also in the same subnet. That means I can reach, this device can talk to my host machine, and my host machine can talk to pnet lab. Do you understand? That's what bridge will do. Settings. That's what bridge will do. So how do you confirm that what I just said? So I'll run through this. So check your pnet lab, check. Okay, we have this device. So I'm able to access it because I'm in the same bridge network as my host. Your host is using bridge. So when you put a VM in bridge, the host, the VM can talk to your host can talk to that bridge. That's why I can access it. So I've allocated 196 gig for this now. So this is what my capacity can do. So if I start turning on these guys, one by one, something will start happening. So we will try to demonstrate how you can install pnet lab. I still want to show you what's you see, I've started some devices here. And if I look at this system, you can see it's increasing. Why? Because those devices are booting up from office. That means you would, okay, what you would do is you would need something like an RDP. And please listen. You will need an RDP or Tailscale. You need a VPN or an RDP connection. You just need a connectivity from wherever you are to your laptop. That means your laptop will always be on, or your server will always be on. You can use Tailscale, you can use RDP, you can use RDP. Now, there will be an internet connectivity in wherever your laptop is or wherever your pnet is. It's as the same thing as you hosting it on AWS. Or you understand? I've explained it if you're following me. So, do you understand now? I can move on. So, you need to do some kind of VPN connectivity or whichever, or SSL connectivity. So, a bridge network, I've explained it, it will only give you a subnet. I didn't mention something. There's a lot I want to tell you, but maybe we'll have another time. And let's just go down to it. So, there's a difference between a simulator and an emulator. So, an emulator, a simulator is just, it will just give you a vibe of what you will see in production. Something like a packet tracer. It's free, it's all real images, it's good for CCNA. EVNG is free, real images, CCNA, CCNP. The community version is free, but the professional is not free. pnet lab, that's why we're using it. It's free for most learners. The only Cisco is need license, but the 5 nodes CML is free also. But personally, I don't buy. You can buy the big, if all you want to do is just within 5 nodes, you're good. Do you understand? So, and one of the problems that you will face when using PNetLab is the image problem. Has anybody faced that image problem? Anybody? Just tell me. You face image problem. You spin up your PNetLab successfully, you open the topology, but your image are not working. Image files are not working. Research is not working. What would you do? The solution is for you to use iShare 2. Use iShare 2, or you do what I just explained here. I just told you that download from LabHub, you download that image from LabHub. The only issue you face is that the naming of those devices might give you issue. You understand? There's a lot when it comes to this. This is another webinar on its own. Image. You understand? We have different types of images. We have IOL, we have dynamics, we have camo. Do you understand? So the capacity of these devices, depending on the image, the iOS on Linux, like this IOL, it has less overhead. It's like 50 megabytes, 100 megabytes. The dynamics are heavier, and the camo they can be up to 7 gig. Now let me show you what that means. So peanuts, let me go back to my peanuts. So there's something we use that is called iShare 2. It's like, so iShare 2 is a repository on GitHub that lets you have access to LabHub devices. So LabHub is like an hub where all these devices, now LabHub is where all these devices are on, all these images are on, but iShare 2 is a program that lets you pull automatically inside your PNetLab command line. So what am I saying in essence is that so hold on please. Wow. iShare 2 search, let's say I want to search a Cisco device, search Cisco. Okay. I can hardly see my, sorry. Okay. iShare 2 search Cisco. Packet tracer is golden for me. I love packet tracer. If I've taken any class that we attended before, you know that I love packet tracer, especially for CCNA level, even for CCNP level. There are some things that packet tracer will do. CML will not. All these simulators will not give you. There are simulators that, like the NetSim, they are for research. There are simulators for research, and I want you to go when you leave this webinar. I want to go and research from. Aside from all these popular ones that we know, there are simulators that are used to test connectivity. They are used to test cable and fiber, to test production. It's a research environment. You understand? And aside from all these simulators, you can use for Huawei. If you want to do some Huawei labs, it's better you do Huawei labs using physical environment. Huawei labs has physical environment. Cisco also have physical environment that they give us on Catalyst centers. Cisco Catalyst Center is also an environment whereby you can do some advanced lab, DevNet labs, Catalyst lab. Cisco DNA or Cisco Catalyst Center is also another cloud-hosted labs that you can have simulation that feels like real devices. You understand? And there are other partner labs environment whereby you can do proof of concept, whereby you can try to simulate what will happen there. Exactly what is happening in that lab is what will happen in your production. At least 90% or 98%, that's what will happen in production. If we are talking about labs from now till morning, we'll keep talking about it. Especially I'll continue talking about instances. Okay, I discovered a colleague showed me a particular environment 2 days ago. Have you heard of New Labs? It's an AI New Labs .ai or something. Okay, So this lab is like an AI. You'll be telling AI to do one or two for you. We try to invest in. Yes. And it doesn't cost you money, it just costs you your time and stress. Things the issue, let me leave that NOLA. But go and research on that NOLA on your own because it'll take our time and necessary. So I can see, okay, no matching images were found. Let me say I share to search IO. So these are the iOS devices that you can find on iShare2. iShare2 search dynamics. Is that correct? So you can pull any of these. You can see dynamics are, you know, the IOL devices too. The sizes are very, you know, yeah, you can still bear, can download all this. They are very lightweight. Now let's go to Kim. I share to, you know, search Kim. Search Kim. So look at Kim. You can see the sizes. But those devices are cool. Some of them, most of them might not work. That's an assignment you do on your own. 1.2 gig, 2 point something gig, 4 gig. I think I've seen a device of 4. I think Windows servers are 6 gig. This is a 9K device. So WLC, you have 6 gig device. So depending on the kind of image that you're downloading, depends on how heavy they are. So how do you save your work? Now your lab instance and your lab just crashed. VMware will crash. Pinet lab will crash on you. So how do you save your work? So you do VMware snapshots. What is that? Let me show you quickly. You take one before any major configuration change, roll back in 30 seconds, whatever. So what does that mean? So I'll come here, this VM, and I'll go to snapshots, and I'll take snapshots. Depending on the kind of type 2 hypervisor or type 1 hypervisor you're using, what snapshot does is that it takes a screenshot of your progress, and it mirrors that particular progress and give you, that means you have access to iShare2 is what you use. Once you install your PNet lab, there's a process whereby you install your iShare2, everything will be perfect. The demonstration I just did now is enough. Or you go to, if you want to see those images yourself, let me show you. Lab, just say lab. So this is lab. The same devices you see on iShare2 inside your CMD, inside your command line, is also the same thing that you see in Labo. Those are the same devices that you see in Labo. It's like a repository for all these iOS images, for all these images. So you can see add-ons, dynamics schema. This is where your device is in. You can see. So if you can't find them here, you see, just go to Labo. You see all most of the devices are being, you see almost all of them here. So you download here. Once you download, you come to your whatever terminal that you're using. Then you do your SFP. You go here and you access your PNets. So anything I copy from here, I can put it. Where will you see your devices? Now let me show you. This is, I'm in PNet Lab root. So then you go to Unit Lab. You go to Ops. EVNG terminal, iShare2. I'm not sure. No, this is the process. I'm not sure. I can't remember. I think this is the only process that I use to add devices on EVNG. It's been a while that I use EVNG. This is the process that you use. Usually, this is what you use. And you do iShare. I think iShare2 is local to PNet Lab. So you come to, from Ops, you come to Unit Lab. Then from Unit Lab, yeah, I'm correct, right? From Unit Lab, you come to add-ons. Then you see the same thing you're seeing here is what you're seeing here. Do you see? So I think one of the struggle that most of us we have is how is our Linux skills? You just need a little bit of Linux skills to be able to an SFP, terminal, SSH. You understand SSH access and telnet access. You use telnet when you want to have. In Mobex time, I use telnet to access each and every devices. To access PNet Lab route, I use SSH. So we have KMU, so inside this KMU, let's say I downloaded a KMU device. I'll just copy it from here and drop it here. So let me try to drop something. Although, let me see. Maybe I have some devices. So wherever it's saved inside this is where my local machine is. My C. And wherever those devices are saved, let me find one device that I can. Users. Let me find one device. So this is a device, and it's a KMU device. It's 1 point something gig. So I can just copy it, but it is not. This is a zip file. It will not work. But let me copy it just to show you guys how to copy. So I just drag it here. I'm copying already. So I can discard it. So when I finish copying, let's say I finish copying, I need to go back to PNets here. Is it that there's something called fixed permission. Okay, if now we are done already. So we fix permission here with a command, or you come here and you do fix permission. Whenever you change anything inside PNet Lab root, you must fix the permission. Let's go to, you close the lab, and you come to your system settings. There's a lot you can do with PNet Lab. Don't worry, we'll do videos for us to see a lot of things. System settings, where's my system setting? System settings. Then you fix permission. You can see it. So every changes that you make inside the roots, you need to fix permission, or else the device will not show, it will not work. You understand? So you can stop all node, you can shut down. Running CML, PNet Lab is another, I think is another class on the team. And labbing is another. But these points that I will explain to you guys today are the major things that will stop you from labbing. Image issues, your architecture, your Linux skills, and a lot of things will determine how you determine how you lab. Maybe you lab or you not lab. A lot of people here have not been labbing because they don't even know how to go about their PNets. The architecture is strong. You're struggling with architectures. So my advice is take your time, use PNet Lab. It's free. Take your time. You can dedicate like a week to find your devices, find your switch, layer 2 switches, find your layer 3 switches on PNet. You try this, it doesn't work. Remove it, add another one. Using iShare to go to Labo. You can actually reach out to some people and ask them, which particular image have you been using that is working? I want to load them in my lab. You understand? That will save you a lot of time and a lot of stress. So, and that is that. I think we've used more than time that we were supposed to use. And I also have another class by 8. I'll need to leave you guys as soon as possible. So how do you save your running configuration? I say VMware snapshot. I've shown you that. You save your configuration. How? You have access to your devices. How? Do you know how to have access to your devices? The terminal of all these devices. Whichever terminal that you are using. I use mobile stand for lab. I just hope you know how to do this. So I'll access the device, then I'll copy their configuration from the screen and copy it to the file. So that file will be on my host machine. What I will do is that I'll run a git. Let me see if this device is it on? It's not on. Okay, this one is on. So if I say show run, so I can copy this running config directly, right? And on my device, I can have a file. I can have a folder on this device, I can have a folder. So if I have a folder here and say create new folder, if I create new folder here, I say lab 1 on my host machine. I say lab 1 and I open a Git bash. This might be too much for a lot of people. Git bash will let me have a Linux interaction with my host machine. So, and I do pwd, I see where I am, and I go to cd d. Let me see here then. Don't worry, you have recording. So if I ls, I do cd. Let me copy this part. Let me copy this part. Copy address, and let me see if I can. I cd. So I'm inside this lab. I'm inside this folder. You understand? So I can say touch touch isp1 isp1.txt if that's possible. So if I ls, I have isp1.txt. You can see I have it here, right? It's already here. Now I can say nano, if that works, isp. So inside here, then I can insert, I can paste what I copy here, the configuration here. As I highlighted it, I copied it. I can paste it here. Are you seeing this? So I would Control X and I will say, it's writing. If this process is not too much for you, so if I cut ISP1, I have the same thing I have here. The configuration I have it on my host machine here. So what I would do to this folder in my Git bash is that I will say, I'll check if Git is here. Okay, I have Git. So if I say Git init, is that a command? So I already have Git inside this. So what would I do? I'll connect this Git. If I check the folder, so this is a Git folder already. So I'll just be pushing this particular folder to my GitHub. That's another class on its own. I didn't even know we can get to this point. So this is another way that you can save your config. You don't want to come back and tell me that you don't have your, because sometimes your laptop will crash. So you have a version control that you have, all your labs have been saved in your what? In your GitHub. That means you are hosting your configuration in your lab. So you can have a README file, you can have your README, you can have your devices. So whenever anything happens to your lab, you can just copy those configuration and run it back. That's another one. What other option do we have? I think I still give us another option. So you can also export your topology. If I go to VMware, no, if I go to my PNet lab, I can also export my topology. So let's go back to my lab, min. So if I go to this lab, I can come here. Can you see this? Exports. You can export your lab, right? You can export, you can create a new lab. If you export this lab, now I have it here. If I keep it, so this topology is what I will go and do. What I'll put it in that Git file. I'll copy this guy, or I extract it. Extract all, and I'll copy it. So extract. So I'll copy this and put it inside my lab 1. So what I just did is that the moment I connect, you know how to do version control from Git, from your local Git. So this is a good local Git environment, version control environment. So whatever changes I make, I'll just git push. So if I git push now, it will tell me that I'm not connected to any GitHub repository. Fatal detected, dubious ownership, blah, 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 blah. Lab is on file, system does not record ownership. You understand? So if you're conversant with version control, you're conversant with Git, you know all other processes that will come. I think this is where I'll stop because of our time. I don't want to be rushing things. You might not follow up anymore. So I think that's all. So I thought we'll be able to do a live demo of something like HSRP, but we can. So just follow our NetClan community. You can, Cisco D Cloud is not, it's for partners. You can use DevNet Sandbox. So Jamie's IT Lab. You can also follow me on GitHub. So this is my GitHub handle. You can find a lot of labs. I've done a lot of labs that you can emulate. You can just, most of them are packet tracer labs. So it's like easier for you to relate with them. They are big, but they are still labs that you can do. If I open packet tracer for you now, so let me shut down. So I think I'm done. Thank you so much for joining. I hope you've learned one or two things from this.
Thank you very
Yeah.
much. Thank you very much, Mr. Mubarak. I had
Yeah.
said that this session was going to be impactful, but it was way, way, way more. Thank you so much. I didn't even dare to stop it when I was supposed to, because I know some persons were going to bite off my pinky finger. Thank you so much. I don't even know where I should start thanking you from. The quality of the webinar was top notch. And I love the rendering, right? Mr. Mubarak did not just tell us, okay, you know what, just do this, just do that, just choose spin it, just spin it this way. He goes to tell you that even if you think you're doing the right things right, these are the problems you could face, and this is how to navigate it. So, right, let's appreciate Mr. Mubarak. This was such a wonderful session. So, more like a finishing note, what is the best advice that you've ever received? Career advice.
For now, I would say don't stop labbing.
Yeah.
Keep labbing. You don't have any excuse not to lab. You see, you read a theory, if I read OSPF, I can read it many times. But you see, there's something called muscle memory.
Mm-hmm.
The configuration doesn't leave you. It's not in your brain, it's in your fingers. So the moment you might think you've forgotten something, the moment you place your fingers on those keyboards, your brain will catch it up. Muscle memory, your brain will keep, just lab. But make sure that you study the theory behind every protocol. Lab is just 10%, believe me. The idea behind every protocol is 80 or 90%. So please practice, 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 and practice. It separates you from everybody. You understand? Now, everything I'm discussing here, you wouldn't believe that aside from the fact that I prepared my slide, everything is coming from my brain. Why? Because it's part and parcel. It's something I do almost every time, so I don't need to stress. So you can also be like that. I have people that I look up to. They do this thing almost every day. It's their food. So I'm not saying use all your whole life to lab it. No. You know, balance it. But please lab.
Wow.
Thank you.
Thank you. Thank you very much. That's all. That's all, Mr. Mubarak. Thank you. We have come to the end of our webinar. And thank you very much. So see you next month. Same time, same place, but different date. All right. Thank you very much. So this our session ends in 5, 4, 3, 2, 1. See you next month.